The twin Voyager space probes first embarked about a month apart from each other on their historic interplanetary expedition in 1977. In 1989, only 5 days after the 12-year anniversary of its departure, Voyager 2 became the first and so far the only spacecraft to fly past the planet Neptune, which orbits at a frigid 2.7 billion miles from the Sun. Since then, Voyager 2 has only grown more and more distant, now leaving our solar system behind at a velocity of 34,000 miles per hour. In 2018, more than 41 years after its launch, Voyager 2 crossed the threshold between our solar system and interstellar space. Although there are no more planets for Voyager to explore, the probe continues its decades-long mission into the vast and unknown regions of the cosmos. What did Voyager discover along its journey? Which one is likely to reach the furthest into the universe? And what is that strange humming noise? Well, let's find out. Voyager 2 is now nearly 20 billion miles from Earth, more than 200 times the distance between the Earth and the Sun. Voyager 1 and 2 both left home around the same time, but because they're heading in different directions, they're actually now farther away from each other than they are from Earth. Amazingly, even after 4 decades, both probes are still operational and regularly transmit new data back to Earth for analysis. The secret of Voyager's longevity is their power source. Each probe is equipped with 3 radioisotope thermoelectric generators, or RTGs, which contain an amount of plutonium. The heat of radioactive decay is converted into a usable electric current that powers the spacecraft systems. Because the Voyager's plutonium fuel has a half-life of nearly 90 years, it is ideal for providing energy for quite a long time. The fact that the Voyagers have lasted so long has proven invaluable to the world of astronomy. Without these 2 probes, we might never have had a chance to study the unknown that lies beyond our solar system for a very long time. Our Sun is surrounded by an enormous cosmic bubble called the heliosphere. This bubble is filled with plasma that comes from the Sun's solar wind. The edge of the heliosphere is called the heliopause, where the solar wind collides with the surrounding interstellar medium. Before the launch of the Voyagers, the nature of the heliosphere was one of the biggest questions in astronomy. Astronomers didn't even know how big it was, and some even estimated that the heliopause might be located as close as the orbit of Jupiter. But as Voyager 2 sped past Jupiter, then Saturn, Uranus, and finally Neptune, it was clear that the edge of the heliosphere was much farther away, and no one knew exactly when Voyager was going to cross it, or even if it would, before it stopped working. But in 2012, Voyager 1 started to see the solar wind disappear and began seeing a significant increase in particle density around it, indicating that it was passing through that boundary into interstellar space. Voyager 2 noticed the same signs a few years later, officially crossing the heliopause in 2018. Both spacecraft were able to measure the boundary of the heliopause as being around 120 astronomical units, or 120 times further than the Earth is from the Sun. However, the fact that both Voyager 1 and 2 crossed the heliopause at around the same distance actually surprised a lot of astronomers. The Sun goes through an 11-year cycle where solar activity flares and sunspots increase and decrease predictably over time. Astronomers had predicted that during the peak of a solar cycle, the solar wind would exert more pressure on the heliosphere, causing it to inflate like a balloon, then deflate during the quiet parts of the cycle. The Sun's activity had increased between 2012 and 2018, and so the heliosphere should have been measurably larger when Voyager 2 measured it than when Voyager 1 did. But because the twin probes measured nearly exactly the same distance, it means that the heliosphere is much more resilient than previously thought. The reason lies with the interstellar medium itself. There is a weak but measurable magnetic field that permeates the space between stars. Voyager 2 measured this interstellar magnetic field at around 7 microgauss. To compare, that's 64,000 times weaker than the magnetosphere of Earth. Still, about 7 microgauss is about twice as strong as astronomers had initially predicted. The unexpectedly strong interstellar magnetic field is enough to put pressure on the heliosphere, keeping it at a roughly constant size throughout the solar cycle. As it traverses interstellar space, Voyager 2 has made even more unexpected discoveries. Just last year, the probe's plasma wave science instrument indicated that the density of the interstellar medium is actually increasing as it gets further from the Sun. Already, over the span of around 20 astronomical units, Voyager has observed more than a twofold increase in the particle density of the surrounding space. This sharp density gradient is both unexpected and unexplained. One theory says that the interstellar particles slow down as they approach the heliopause, so they begin to pile up like a traffic jam, and Voyager is just now beginning to pass through this piled-up region. Another theory is that as the interstellar magnetic field collides against the Sun's heliosphere, the magnetic field lines actually become compressed, which forces ionized particles away, creating a relatively depleted region between the heliopause and the rest of the interstellar medium. As the Voyagers continue to push further and further into deep space and measure the density of the interstellar medium, it may help determine which of these theories is true, or some combination of both of them. Unfortunately, we may never get an answer. The Voyager's plutonium power sources are steadily decaying as time goes on, and it isn't certain how much longer they will still be able to operate. But before Voyager goes silent forever, it will continue to collect new information from the edge of explored space. Earlier this year, it made another curious discovery, a faint humming sound coming from the interstellar medium. Just as the vibration of sound waves is carried by the particles in the air, vibrations can also be carried through the tenuous plasma of deep space. Because the interstellar medium consists of only a few particles per cubic centimeter, the sound would be far too faint for your ears to detect. Even using Voyager's sensitive antennas, it's taken astronomers a few years to finally hear this strange noise. Shortly after Voyager 1 passed through the heliopause, it detected a series of relatively loud, high-pitched whistles. These bursts of noise lasted only briefly, like a shock wave passing through the thin interstellar plasma. These sounds have been linked to sudden outbursts of activity on the Sun, which sends ripples through space like a stone dropped in a pond. The timing of these outbursts was fortuitous because it allowed astronomers to get a better measurement of the interstellar medium than ever before. However, they only offer a short window into what is happening and show only the effects of intermittent solar eruptions. What astronomers really want to know is what goes on in between those signals. With a continuous measurement of the interstellar medium, they'd be able to get a better idea of its true density and how it fluctuates over time. In May 2021, a team out of Cornell University finally found what they were looking for. By sifting through data from Voyager 1's plasma wave science antenna, the astronomers were able to isolate a new sound, a long continuous hum resonating around the 3 kHz band. Stella Acker, a leading member of the Cornell team, stated that if we could hear this, it would sound like a single, steady note played constantly, but changing very slightly over time. Now, we don't have to wait for a fortuitous event to get a density measurement. We can now measure the density almost continuously. This newly detected interstellar noise is big news and a huge leap in helping us to understand the nature of the void beyond our solar system. By using continuous measurements from Voyager, astronomers will be able to better understand the interactions between the Sun's magnetic field and the interstellar one, and what happens at the boundary where the solar wind meets the interstellar plasma. The space between the stars in the Milky Way remains one of the biggest and most enticing mysteries in astronomy today. Voyager 1 and 2 might be able to help answer some of those questions, but they may only remain operational for a few more years, and it's unsure how much more science they will be able to complete. Some mysteries might stay unsolved, at least until another probe can be sent on the decades-long voyage into the realm of the interstellar cosmos.